Now, what we have to do is to come back, and because what this acidic, aqueous acidic layer contains, it contains the ammonium salt of the p-nitroaniline. So it's dissolved in there just like any other salt would dissolve in aqueous environment. So what we have to do, we're going to put this in an ice bath and chill it. I'm going to stopper it up, and then we will add a base to this to go up to about pH of about probably close to 10. And when that happens, we should be able to precipitate that original p-nitroaniline. So what I'm going to do, this is my aqueous acid. I'm done with this as far as collecting anything else in it. So I'm just going to take some paper towel, stopper it, and then we will put it in an ice bath and let it chill. And the main reason we like to put it in an ice bath, if we add base to that, anytime you add sodium hydroxide to hydrochloric acid, it is an exothermic process, so we want to chill it before we neutralize or make that more basic in nature. So in this trough we have our ice bath, and we have our acidic layer, aqueous acidic layer, which should have the p-nitroaniline in it. And I also have a flask of just distilled water. I went ahead and started chilling that as well, because once the precipitation is complete, then we're going to filter this by Buchner filtration, vacuum filtration using the Buchner funnel, and we always want some cold or chilled solvent, so I've got plenty of chilled water there to use when we do the filtration. So I'm going to use a little bit more concentrated sodium hydroxide solution. We want to get the pH somewhere around, I'm going to say 9 to 10 probably. I think that's where we're going to have most of this to precipitate. If you notice, even though it's been chilling in an ice bath, it still is a solution. You can still see through it. Nothing has crystallized. So what we have to do is get the pH higher at the point where that amine group, or the ammonium salt, if you will be converted back to the amine. Now what I want to do is when I add some of the base to this, I want to stir it, and I'm going to use a stirring rod to stir this. Now kind of take it out so you can see. You should notice right when precipitation starts. I'm just going to hold this up here so you can kind of see. You can kind of see some of the yellow that's first started. It will probably go back into solution until we get that correct pH. And I'm just going to take a drop of this and add it to a piece of, and it's still pretty acidic, so we have a ways to go there. And we did have 45 milliliters or so of the acid, somewhere between 45 and probably 55. So it is going to take, quite a bit to neutralize, or to get past the neutralization point. Still acidic. I don't really like pouring the sodium hydroxide from the reagent bottle into the flask, so I like to pour it from into a cylinder, and then use that cylinder to pour into the flask. Until it looks like we're forming a precipitate. I'm just going to take the pH on that. Not quite there yet. Looks like that. Looks like we are almost there. Looks like we're about a pH 8 and just another couple drops. So now we're at a pH of close to 10, and I just want to pull it out. You can certainly see that we have formed a yellow solid. That yellow solid is our p-nitroaniline. If you notice, when we first used it, it had more of a brownish yellow color. I think some of that might have been an impurity that we saw that remained in the separatory flask. I'm going to let that just sit there and chill for a few minutes. Get ready to collect the p-nitroaniline, a little bit of water in the top of the beaker funnel. Faucet turned on, give a little push. And notice the p-nitroaniline is that yellow color. I'm going to swirl it. Washing with some cold water. I pour some ice cold water inside the Erlenmeyer flask, and just to kind of give it a little more rinse. I'm happy with the filtrate I saw with the benzoic acid and also with the p-nitroaniline. I'm not seeing anything crystallize out, which none of these substances should be soluble in cold water. So that is, I'm happy to see that. Let that set dry for a few minutes, and then we'll come back, scrape it out, get it weighed, and then we'll do also a melting test. It's been several minutes since we filtered the p-nitroaniline, so I'm going to disconnect the vacuum hose. Remember, always do that first before you turn the water off, because you don't really want water to be sucked back up into the filtration flask. And we have our yellow solid that I'm going to transfer to this other filter paper, and then we also have to be careful when I'm scraping the solid off the filter paper. I think I saw maybe a piece of paper, very small, like a fiber, if you will. So we also have to kind of be careful when we're trying to remove it, especially if it's wet, because that paper can tear. I think I've got most of that off. And keep in mind that every time we do a separation, just transferring it from the filter paper to some other piece of filter paper or to a weighing dish, we're always going to lose some material. If someone told me they had 100% recovery, I would believe it. Transfer that to a weighing dish, and we'll get a weight on that as well. Now, what we want to do also, I'm going to take this and put this in an ice bath, because how do we get the benzoic acid to crystallize again? Because it really loves being the sodium salt. So what we're going to have to do is, once this is chilled, we'll add some hydrochloric acid to that to convert it back to the benzoic acid, which is not soluble in water. So it should precipitate out. So I'm going to put this in an ice bath. So now we're at the stage where we've got our aqueous base, and remember, our aqueous base has the salt of our carboxylic acid, so this is the salt of benzoic acid that we have in here. Notice that this is a clear solution, so nothing has precipitated. It's been chilling in an ice bath for a while. Again, once we add the acid to this to precipitate the benzoic acid, we'll filter it by vacuum filtration. Again, I have more cold water over here. The pH we want to get down to about 2. Somewhere between 1 and 2 is good to make sure all of that benzoic acid crystallizes out. Added some, as you can see, it's still a fairly clear solution. And I'll just do a pH test just so that you can see. And certainly that is basic solution there. And we do have the indicator pH paper, so we pretty much know, we can tell fairly quickly what the pH of that solution. looks like it's turning more of about a 7 or so. So we'll still add some more. You notice we formed a white solid. That white solid is our benzoic acid. So let me check the pH of this. I'm going to stir it really well. You can see that's pretty close to a pH of about 1 to 2. So we've added enough of the acid to that. So it looks good. We're going to let that just sit there and chill for a little bit. So we're going to collect the recovered benzoic acid. We're going to use the vacuum filtration. Remember, we always want to hook up the hose to the aspirator. We're going to add a little bit of water to that to help the filter paper stay in place. Typically, you only open one faucet, but in our school we have to do both. And then I'm just going to kind of give a push on that butyl funnel to make sure there's a pretty good vacuum being pulled. And then I'm going to take our recovered benzoic acid and pour through the top of the butyl funnel. I have some ice cold water here. I'm just going to add to the flask. Hopefully I can catch anything that didn't filter in here. Wash these crystals. And maybe do that. And then we're just going to let that kind of suck dry for several minutes. Then what I'll do is I'll take this out, squeeze it between filter paper to dry it as much as I can, and then we'll do a weight and we'll do a melter point. I'm going to go ahead and remove the vacuum. Ideally, it would be best if we could dry this a little bit, but as far as just kind of showing you the procedure itself, I'm going to go ahead. It's not sticking to the spatula, but I'm still not 100% sure that it's dry. So I'm going to go ahead and get a weight. This is my organic layer. Again, the neutral, and I'm going to stress neutral because at this point we should have gotten rid of the benzoic acid, we should have gotten rid of the p-nitroaniline. So what I'm going to do is I'm going to take this and I'm going to add some sodium sulfate. It is possible that we could have gotten, some, when I say that it should be mostly the naphthalene or neutral substance, because when you're doing the separation, it's almost impossible to stop it at the exact point where the two layers separate. So it is possible that this could have some impure or some benzoic acid in there. It could have some of the p-nitroaniline in there, but mostly it should be the naphthalene. So I'm going to add some of the sodium sulfate to this. Just going to add some, swirl it. If it looks like it's swirling and not clumping together, and that's what I'm noticing here, doesn't seem like there's anything that's really clumping much. It's moving pretty good, I think. I don't see much of a clump. So I'm going to stopper that and let that sit for about 10 minutes. Then what we'll do is we'll put this in a pre-weighed round bottom flask, and we need to get rid of the dichloromethane. We're going to use a hot water bath to do that. So the water's heating up. About 10 minutes, I'll come back. We'll filter this probably through a pipette just to make sure we don't get any of that sodium sulfate transferred over, and then isolate that. And what we're doing is we're trying to remove the dichloromethane, which contains the naphthalene, from the drying agent. And the drying agent has such fine particles, sometimes it's hard to decant that. So we're just transferring over through a cotton plug and a pipette. That's going to serve as our filter. And then one thing I probably should just mention to you as well, everything has filtered through. The drying agent that we have left in here, I will place that on a paper towel and just let that air dry under the fume hood for a while before we put it in the waste container. Since our solvent has methylene chloride in it, which is a halogen, we'll have to take care of where we place our waste when that time comes. So what I've done is to put this into a pre-weighed 50 milliliter round bottom flask. I'm going to attach it to a clamp because what we need to do is to boil off the dichloromethane methylene chloride. And we're going to use a hot water bath. Methylene chloride has a fairly low boiling point, so I think it's easier to do this and going through the process of setting up the distillation. I just have to make sure everything is clamped tight, as tight as I can get that. And then what I have here, just move that out of my way, is a beaker with some water in it, and I'm going to use that as my heating source. So if you remember, we've done this before. We kind of put it in there and then swirl. We're going to do the same thing here. We don't want to go crazy initially, but leaving it in there. We're getting almost to the final stages of recovering the the naphthalene. You can see that the volume has decreased quite a bit. So usually when we stop seeing foam, that's usually a good indication that all the solvent has been evaporated. There is an issue with naphthalene sometimes. It has been known to sublime, so it's sometimes hard for it to crystallize, in other words. So I'm going to see what happens if we can get all the solvent out. We may need to kind of roll it all around in the flask and see. It looks like it's still bubbling a little bit. Bubbling. I'm going to just kind of see if we can get that to stop. The naphthalene should be more of a white crystalline substance. It's not unusual for it to be contaminated with the other components that's present. Again, as we go through the separation of the separatory funnel. I don't see any more foaming or bubbling, so I think we've pretty much got all the methylene chloride removed. But what I want to do is to kind of swirl that around a little bit. I'm hoping as it cools, it will start to crystallize. I think what I'm going to do is just let this cool on its own, and then we'll come back. I did not notice any more bubbling, and if you kind of look, you may be able to tell when I rotate it around, it looks like there are a few particles that's kind of adhering to the round bottom flask. So just let that cool a little bit, and I'll come back and take a look at that later.
Okay.
These are the crystals that I recovered from removing the methylene chloride from the neutral flask. So this should be naphthalene. Notice that it's not a white crystalline solid, but it is very yellow. So what that tells me is that there is some p-nitroaniline that had gone through, contaminated the naphthalene. Took a melting point, and the melting point started melting at 76 and ended at 79. So that is lower than what the true melting point of naphthalene is. So in terms of impurity, not as pure as we would like, but it's very unlikely that you're going to get extremely pure substances just by an extraction. Typically after an extraction, you'll take those samples that you recovered and probably do a recrystallization of those. So what this method ended up telling us, we could take 3 different organic compounds, mix them together, and get them back again by these acid-base extractions.